Unit 3 is conic sections, and when you think about the word conic, it's talking about a cone. So check it out. I've got this 3D graph on GeoGebra, and I've got like a graph of a cone. And what I want you to imagine is if you took a knife, and the knife is purple, right? And if you took a knife and you just made a slice through that cone, notice the shape that you get is a circle. So I just took a purple knife and I sliced right through the cone and it made a circle. One of the conic sections is a circle. So there are other conic sections. If I make a different slice, check out this slice. What shape does that look like to you? Right, so a different slice might make a parabola. Very good. And a different slice. That looks like a circle, but that's actually an ellipse or an oval shape. And how about this one? This one's the weird one. Because you're going to say that looks like a parabola, but actually what happens is it cuts through both of those cones if you slice it in this direction. If you take your knife and you slice it in this direction, kind of looks like a parabola, but that's not exactly the same pattern as a parabola, so we wouldn't call it. It's going to be called something different, called a hyperbola. But for today, we're going to be concerned with this type of conic section, which is a circle. 3.1 is circles. And I've got a picture there of the 4 different conic sections. And in this particular one, we're going to look at what happens when you take a cut like that. You cut right through a cone, and that cut is going to make a circle. So box in this equation right here. That is the equation of a circle, and you're going to need that a lot. In order to draw a circle, you need 2 main pieces of information. You need the center of the circle, and you need the radius of the circle. And what's nice about this equation is you can see it pretty quickly. The center point of the circle is just going to be the point h comma k. And so you're looking at this number and this number right here. That's going to give you the center of the circle. And then the radius is going to be r, of course. Now you might notice that they give you r squared here, so you have to do something with that number, but it's pretty easy when you're looking at that equation to find the center and the radius. Example 1 says, find the center radius form of the equation of each circle described. So that's what we just boxed in. That equation is the center radius form of the circle. So it's not that big of a deal. It's not that tough to do. All you need to do is look at your x number and your y number, and then you've got your r number. So here's the equation. We're going to say x minus 1 squared plus y minus negative 2 is going to change it to plus equals. Now the trickiest part is you're not going to put equals 3. You've got to put 3 squared. So in this case, 3 squared is going to be 9. And that's it. That's all there is to it. You've got an equation of a circle with center at 1 comma negative 2 and a radius of 3. So then if you look at part B, when it's a 0, it's a little bit different, and sometimes people get tricked. But I'm not going to write x minus 0 squared. That's not simplified. I can clean it up. I wouldn't say x minus 0. I would just say x. And likewise, same thing for the y. I could say y minus 0 squared, but that's not how you're going to see it. When you see it written, it's going to be x squared. It's going to be y squared. And understand when the number's missing, that means it's a 0. And then if your radius is 2, we're going to square that. And so that equals 4. That's a circle with center at 0, 0 and radius 2. Now we're going to graph. If you're going to graph a circle, the best thing that you can do is find the center point and the radius. If you can find the center point and the radius, then it's really not that bad for graphing. And so, we're going the other direction. We're going the other direction. We have an equation. We want to find the center. We want to find the radius. What I like to do is think about what number makes this equal 0. And a lot of times people will say, well, it's the opposite, but I don't like that because it's not very mathematical. But I can see my x number is 1 and my y number is -2 right there. What makes this 0 is -2. And so that's my center point. I might label it like this. That's my center point. As for the radius, remember that this is r squared. And so my radius is not 9. You're going to end up having to go backwards and undo that. So it's the square root of 9. It's 3. And so here's what I'm going to do. I'm going to find that center point first, 1, -2, and put a dot there. And then the easiest way to graph this, I think, is to go up, down, left, right, 3 units. So go 3 units in each direction. I'm going to go 1, 2, 3 to the right, and 1, 2, 3 up, and 1, 2, 3 to the left, and 1, 2, 3 down. If I can get those points, then I should be able to draw a decent looking circle. So take your time. It's not bad. Okay. So then if we look at this one, remember, when you've got this by itself, it's because the number is what? 0. So this center point is actually at 0, 0. And this radius, square root of 4, is 2. So I'm going to start at 0, 0. And I'm going to go in each direction, up, down, left, right, 2 units. I've got those dots. Try really hard to draw a decent looking circle. And there we go. Now at some point you're going to have weird numbers. So let's say I had a different equation. I'm going to draw another one. Let's say example C. And let's make this x minus 6 squared plus y minus 5 squared equals 7. All right. So this one confuses people. They're really weirded out by that 7. But you can see pretty quickly that the center point is going to be the point 6, 5. That's not that difficult. 6, 5 is right there. But then when they try to find the radius, they're like, well, I don't know what the square root of 7 looks like. It would be the square root of 7. And I don't know what that looks like either. But what I would do is I would take out a calculator and find the square root of 7 is about 2.6. That's about 2.6. I'm not going to be able to line up square root of 7, but I know what about 2.6 is. I'm going to go about 2.6 and about 2.6 and about 2.6 and about 2.6. I'm going to do the same thing. I'm just kind of eyeballing it up though. All right, you get it? You got the idea? Okay. Now that's all well and good, but it's going to get a lot harder. It's going to get a lot harder when you have to complete the square. This whole chapter is going to be filled with completing the square. The hardest examples, you're going to have to complete the square. And it's going to be in this lesson and the next lesson and the next lesson. It's going to be the entire chapter long. You've seen completing the square. You should know how to do it, but I find students are a little bit rusty and it makes it harder than it should be. All right. So let's remember some easier examples here. If I was trying to complete the square, I would look at this 10 and say half of 10 is 5. And then I square 5, and that's 25. So 25 goes into blank. And that is completing the square. And you can tell it's completing the square if you factor. If I factored that, I need two numbers to multiply to 25 and add up to 10. That's 5 and 5. So we could factor that into x plus 5, x plus 5. But we'd like to write it like this. We like writing it as a square. That's completing the square. Now, the next example is a lot harder. Anytime you've got a number in the front like this, it's going to make it a lot harder. It's more complicated because you can't just take half of 12 as 6 and square it as 36. That's not how it works. You've got to do something with that 2 first. And so what I'm going to do is kind of treat it like a GCF. Factor that 2 out of the problem. If I take a 2 out of the problem, I'd have x squared plus 6x plus blank. And there's going to be more to it than this, but that's an important first step. Now you take that 6, half of 6 is 3, square the 3 is 9, and that's what goes in the blank. Okay? You can factor that, because we just completed the square, into x plus 3 squared. It's just going to have a 2 in the front of it. Now that's not all. There's something else that's going to happen, but we'll save that for a later time. All right, but anyway, completing the square looks something like that. You're going to have to be able to do that to find the next couple of answers or graphs. Show that the equation has a circle as its graph, find the center and the radius. And so that's the key. If you can find the center and the radius, this is easy. You know how to graph it, you know how to write the equation, you know how to do everything. But the problem is I don't see the center and the radius out of this equation. This equation is called the general form, but it's going to be much easier if it's in that center radius form, like we boxed in on that first slide. So here's what I would do. We're going to need to complete the square. What I think you should do is kind of group the x terms together. X squared plus 4x. And then put plus blank. You want to create this blank, and in that blank, that's where we're going to complete the square. All right? I'm going to do the same thing for the y terms. Put the y terms together, y squared minus 8y. And I'm going to create this plus blank so that I can complete the square. And then that minus 44 is kind of in the way. I don't really want to do anything with that minus 44. So what I'm going to do is I'm just going to add it over to the other side just to get it out of my way. So clear that 44 out, move it over to the other side. I don't really care about that yet. It's important. You can't just get rid of it, but move it out of the way. Now, look at your x terms, and you've got this 4 right here. Do what we do. Half of that number is 2, and square that number, you get 4. That's completing the square. If you think about factoring, two numbers to multiply to 4 and add up to 4 are 2 and 2. This would factor into x plus 2 times itself, or x plus 2 squared. All right? Now, here's what's weird. When I wrote that 4 in that blank, I unbalanced my equation. Think of an equation as a balance. And left side equals right side. It's completely balanced. But what I just did was I added a 4 that wasn't there. And so you've got to take care of that 4. And there's a couple of different ways that you can take care of that 4. The first way that we've seen is if you add 4, well, you can just subtract 4. This is not the way I want to do this problem, but it would work. You could do it this way. You could do it this way, and you'd have a minus 4 right there. But the problem is you're going to end up having to add that over to the other side. All right? And you can totally do it that way. There's nothing wrong with that. I just think it's easier to do it a slightly different way. So here's what I would do. When I add that 4 to the right side, or to the left side, I'm going to say, well, if I add it to the right side also, then it'll be in balance. So my rationale is this. If I add 4 to the left, I'm going to also add 4 to the right. That will balance my equation, and it's like no harm, no foul. I didn't really do anything bad here. All right? So that's important. If you don't do that, you're going to get this wrong. Now I'm going to work on the y terms. See this minus 8? Half of that is minus 4. It's not half of 8, it's half of minus 8. So that's going to be minus 4. Now, when you square this, even though it's negative, once you square it, times itself is going to make it positive. This number will always be positive. That's why you can go ahead and put the plus sign in front of it. It will always be positive after you square it. But I'm adding 16, and if I factor that, two numbers that multiply to 16 and add up to negative 8 are negative 4 and negative 4, or y minus 4 squared. Now again, that 16 is not supposed to be there. So I either need to subtract 16 or add it to the other side. I think it's probably easier to add it to the other side. And so I just kind of clean up my equation here. I've got that plus sign here, and I've got an equal sign here. And those of you that are ahead of me, what's 44 plus 4 plus 16? What? 64? Great. That's my equation. Show that the equation has a circle as its graph. Well, that's an equation of a circle. That is an equation of a circle. It looks just like that thing from before. But we also want to find the center and the radius. Well, that's no problem now. Now that we've got the equation, we can see what, negative 2 and positive 4 right here. So we've got the center point is negative 2 comma 4. And the radius, anybody know what the radius is? Radius is 8. Very good. We're going to have to do the square root of 64 to get 8. Okay? So then problem number 4 is really the same thing. I could have given you a harder example, and we will, but it's basically the exact same idea. Let's put our x's together. We've got x squared plus 12x, and leave a blank space. And then I'm going to put my y's together, y squared minus 10y plus a blank space. And yes, it is always going to be a plus a blank space. And I'm going to subtract the 41 over. Just kind of clear the 41 out of there. There are other ways to do this, but I think this is the easiest way to understand. Now, half of 12 is 6. Square it's 36. Factor it, that's x plus 6 squared. But I messed up my equation, right? I unbalanced my equation. If you add 36, that's not there. You just create that out of nowhere to try to solve a problem that we have. You're going to need to balance your equation out. And that's one way to balance it out. If you add 36 on the left, better add 36 on the right. Now we've also got this minus 10, so half of that is minus 5. Square it is 25. I do that to complete the square. Y minus 5 squared. Oh yeah, I unbalanced my equation again. Plus 25 on the left. Let's add 25 on the right. Now it's going to be balanced. So anybody ahead of me? Negative 41 plus 36 plus 25 is 20. It gets confusing when we get a weird number like this that we don't know the square root of. Okay, we don't know the square root of 20, but that's okay. This is my equation. We know that's the equation of a circle. We can see the center is at negative 6 comma 5, and the radius is going to be whatever the square root of 20 is. And so you might pull out your calculator and figure out that's 4 point something, but you should also know how to simplify a square root. We've done this. We know that 20 has a 4 in it, and square root of 4 is 2. So the best answer is going to be 2 times the square root of 5. If you're graphing, though, if you had to graph that, you might just plug in square root of 20 and go about 4.5. That's about 4.5, 4.47. So if I was graphing it, I'd go over about 4.5. Now, this is my equation of my circle, right? And there are some interesting things that could possibly happen, right? If r is greater than 0, and that's like what we've seen. When we had x squared plus y squared equals 4, we can see that this is a circle. The graph is a circle. Nothing interesting or unusual about that. That's like all the other examples. But if r is something else, something strange occurs. Right now, we've got a circle with radius 2, and that's fine. We've got a circle. It's got a radius of 2. All right. Nothing wrong with that. Nothing weird about that at all. But if r equals 0, if r equals 0, then this graph is no longer a circle. Think about it. Think about a bubble. You've got a bubble with radius 2, but it's shrinking, it's shrinking, it's shrinking. The radius shrinks down to 0. What are you looking at? That's a point. If the radius is 0, that's not a circle anymore. That'd just be a point. And that could happen. But then the third case, if r is less than 0, that's the really weird one. If I had x squared plus y squared equals negative 4. Think about it. If, normally what we do is we take the square root, r equals the square root of that number, and the square root of 4 was 2. That's how I knew that was a radius of 2 before. But if I'm going to do the square root of negative 4, that's imaginary, right? We just did that in our last chapter. That would be like 2i. And if it's imaginary, then that means we can't see it. We can't visualize an imaginary, or imagine this bubble. It's shrinking, it's shrinking, it's shrinking down to 0. And then what if it keeps shrinking? I don't even know how to imagine that. You got a circle that shrinks down to a radius of 0 and then negative. I don't know if that's like an implosion or what. So you could say something like non-existent. You're not gonna be able to graph it because it's got an imaginary radius. So then number 5 is going to use that concept and say, what is this? Is this a circle, or is this a point, or is this non-existent? But guess what? In order to do this, you need to do that same completing the square so you can figure out the radius. So we're doing the same thing again. The hard part of this chapter is going to come up over and over and over again. X squared minus 6x plus something, plus y squared plus 2y plus something. And the 12 is already over there, so equals negative 12. That's already out of the way. We complete the square. So we're going half of negative 6 is negative 3. Square it is 9. Remember, it will always be a plus. Once you square it, it will always be a plus. X minus 3 squared. And then half of 2. Everybody misses this one. Half of 2 is 1, and you square that number and you get 1. A lot of people will miss that one. Okay, so we can complete the square, but don't forget, we just unbalanced our equation, right? That 9 was not there. We did that. We unbalanced our equation, so let's rebalance it. If you add 9 on the left, you better add 9 on the right. If you add 1 on the left, you better add 1 on the right. And so my new right side is negative 12 plus 9 plus 1 is negative 2. And forget about the center. The center point doesn't matter for this question. What matters is you would be trying to find a radius of square root of negative 2. And square root of a negative is going to have an imaginary part. And we can't even visualize an imaginary radius. We don't know what this looks like. And so what's the answer? Is this a point or is this non-existent? This is non-existent.